All right, so continuing on with fractions. If we have fractions that we are adding, and the denominators are not the same, then we have to make them the same in order to add or subtract. Because the rule is we add and subtract the numerators over a common denominator. Now, there are a lot of common multiples between 13 and 26, but what we want is always the smallest one. And since these are denominators, we call this value to look for the least common denominator. So the smallest number that both 13 and 26 divide into evenly. So in this case, LCD is 26. 26 is the smallest number that both 13 divides into it twice, and 26 divides into itself once. And so LCD here would be 26. And so the objective is to write all denominators to have that LCD. Now, the only thing you can multiply something by and not change it is 1. So what I do is I multiply whatever is needed. And since this is the LCD, 13 will divide in there evenly. That means it will be times some counting number to get me 26, which in this case is 2. So 2 times 13 will give me 26. And we multiply fractions by multiplying again across the top, multiplying across the bottom. Now to keep this 1 and not actually change this, just changing its form, I just make sure that I multiply the top by the same thing that I multiplied the bottom by. And then I go ahead and multiply my numerators. And I'll have 10 in the top, and then 2 times 13 is 26. Then at that point, I am able to go ahead and add the fractions. And again, I add over that common denominator, 26, and then in the top, 10 plus 5 is 15. Then I have to consider, can I reduce it? In this case, no. That 15/26 is reduced as much as possible, meaning there is no number other than 1 that will divide in the top and bottom. 2 does not. That's odd. That's even. 3 does not. 3 will divide in the top, but 3 will not divide into the bottom. 5 won't. 4 does not. So that would be my final answer there. And so really what we're looking at is, again, in this section, adding up fractions which have unlike denominators. Any questions on that? All right.
No.
So, yes, sir.
No, I don't have any questions. I get the easy ones quite well.
Okay. Well,
But
let's.
the big help that I think was when we spoke last week and you showed me how to use the calculator. It's been
Sure. Yeah.
It's
now,
been a great help.
good deal. So the biggest thing to you make sure you can do it by hand, though, even with the aid of the calculator. What we're really wanting to make sure we got are these underlying principles of how mathematically this is done. So let's look at a problem that has a little bit more to it. So this was, and we are looking at section 2.3. I have assigned up through 2.2. This was actually number 2. I'm going to skip ahead to number 10. Now, this one's got some words in it. The problem says a book cover is 9 4/5 inches by 13, 22, 25th inches. What is the total distance around the cover of the book, which is what we call perimeter, meaning it's just a rectangle. We'll assume we got a rectangular book. I can't draw a straight line, but so here you've got the 9 4/5, which if it's a rectangle, it means this side is also 9 4/5. Then this length is given to be 13, 22, 25ths. All right, so we have mixed fractions here. Okay. And so if we're going to find a perimeter around this, it's really an exercise of adding this all up, all four of those numbers up. So I want to step aside before we do this, back it up for a second, and talk about adding mixed fractions. If we're multiplying or dividing mixed fractions, we have to convert them to improper and then multiply or divide accordingly. And then we could rewrite them as a mixed fraction if we so wished. But if we're adding, say I've got 2 3/4 plus 3 5/8. So simplify the problem a little bit. Nice thing about adding mixed fractions is I don't actually, and it's much easier to not change them to improper form, to leave them as mixed fractions. That is, we'll add the fractional part, and then we'll add the whole part. And so when I look at adding the fractional part, what I first notice is I've got that same situation here. My denominators are not the same. So I would look at rewriting each of these to have the same denominator, which our LCD here between 4 and 8 would be 8, 8 being the smallest number that both 4 and 8 divide into evenly. So I would rewrite this one such that I'm going to multiply top and bottom by 2 because 2 times 4 is 8. So I'm going to just put a little arrow here. We're going to come over. We're going to say we've got 2 and 6/4, which I know that's improper. We'll just leave it as it is. We've got that denominator to be 4 plus 3. Oops, I said 6/4, and it is 6/8. 2 times 4 is 8. That was the whole point, to get that to be 8. Anyway, and didn't have to rewrite that one. Now, I add up the fractional parts. This is where we may encounter getting an improper fraction. When we add them, 6 plus 5 is 11 over 8. And then I can add up the whole part. 2 plus 3 is 5. Now, we won't want to leave our answer like this because this is improper. So what I'm going to do is to rewrite my answer. 11/8 is, I think about this is more than 1. 11 over 8 is more than 1. If it's improper, it's definitely the number itself. That fraction is more than 1. But what I can do is take away 1. Now, 1 can be written infinitely many ways as a fraction as long as top and bottom are the same. So I choose to write it as 8 over 8. I mean, I could write it as 2 over 2, 3 over 3, 4 over 4. I choose 8 over 8 because that denominator was 8. Now, that is going to leave me with, we add and subtract the numerators. In this case, subtract the numerator over the common denominator. And 11 minus 8 is 3. So if I take away 1 from 11/8, I'm left with 3/8. Now that 1, because remember, this is 5 plus 11/8. So the 1's got to go somewhere. I took it away from here. I just added to the 5. So 11 and 5, 5 and 11/8 is the same thing as 6 and 3/8. Again, I took the 1 away from here, leaving me with 3/8 in the fractional part. And then I added that one that I took away to my whole part here. And I got my final answers of 6 3/8. All right, so any questions on that? Working, adding, subtracting mixed fractions.
No.
Okay, so that brings me to this problem, which was, again, it's just adding up these mixed fractions. It's just the numbers are a little bigger. So now, one way, if I were approaching this, I would actually write it this way. Since this and this are the same, there's two of them. So 2 times 9 4/5. And then there's 2 of the other lengths. So 2 times 13, 22 25ths. And then it's just simplified this. So you can go 2 times 9 is 18 4/5 plus, and then 2 times 13 is 26, and then 22 25ths. And so we'll do the same thing again, where I'll add the fractional part and I'll add the whole part. And then if I need to, I'll rewrite my answer like we did in the previous example. So I look at the fractional part. That has a denominator of 5. That has a denominator of 25. So the LCD is 25, which says, all right, to rewrite this, I would multiply top and bottom by 5. And now that was going to give me 18, 20 in the top, 25 in the bottom, plus 26. And so now each of these have a denominator of 25.
It's pretty, right?
Yeah.
All right, so let's put a little divider here. And so I can now add up my whole part, 18 plus 26, which would be 34. And then add up the fractional part, and common denominator 25. Now, 20 plus 22 is 42. So I've got 34 and 42 25ths. And so we got that same situation as we did right here, where this fractional part of my mixed fraction answer is improper. And so I take away 1 by going 42 25ths minus 25 over 25. All right, so, and that's going to give me 25 in the bottom. Now 42 minus 25 would be what, 17, I do believe. And that means that this would be, again, we've taken away 1 away from there, brought it to here, so that's 35 and 17 25ths. So all the principles are the same. It's just numbers were a little bit bigger. And I'm punching this one as into my math lab, and uh-oh, something went wrong. What went wrong? Oh my goodness gracious. I apologize. 18 plus 26, and I said it was what, 34. That should have been 44. That's what I get for adding in my head. And my apologies again, which would make that 45. The fractional parts were good. Oh. 6 plus 8 is Okay. I think I know what happened here. All right, gang, I apologize. I just made a about right mistake here. So I'm going to put a little asterisk by this. And I'm going to put an asterisk right, we're good here. I'll put an asterisk right there because that's where I've got the problem. And silly that I did this. 2 times 9 is 18. So when we were talking about mixed fractions previously, we had discussed that this is actually 9 plus 4/5 is understood to be an addition there. And that means the distributive property should have kicked in or does kick in. And I didn't. I left that at 4/5 when actually that should have been 8/5, which is not the same thing as 4/5. And so from here on, the arithmetic was correct, assuming that number was correct and assuming that number was correct. All of this is correct. So I actually made 2 mistakes on this. And I do apologize. So I don't want to erase this. As I said, the mistake was right here and where I got the asterisk. Because when you do it this way, you're saying 9 4/5 plus 9 4/5, which would have given you 9 plus 9 is 18, and 4/5 plus 4/5 is 8/5. And again, I did not multiply it here, so I've got to do this one more time. So I'm going to run out of room now, so I'm going to just basically do this problem again, but get it right. So we said 2 times 9 4/5. I'm a little bit embarrassed I did that. But so making that adjustment, again, if you're multiplying, you've got a mixed fraction times a number, both of these have to be multiplied since, again, this is understood to be 9 plus 4/5. And distributive property says both have to be multiplied by that. So that would be 18. And when you multiply by this is like 2 over 1. So 2 times 4 is 8 over 5. Plus then 26. Now 2 times 22 is 44. Okay, so proceeding on with this, I would still again need that common denominator. So LCD is 25, multiply top and bottom by 5. And I would have 18 over 440, because 8 times 5, 40 over 25, plus the 26 and 44 over 25. All right, so now let's add up 18 plus 26, which again is 44. And adding up the fractional parts, 20 over this over my common denominator, 25, and 40 plus 44 is 84. Okay. Now, in this particular case, again, you want to get this to be proper. So in my previous example, I took away 1 because that was as much as we could take away. In this case, I actually can take away, so I would have 84 over 25. So if I take away 1, 84 minus 25 is 59. And so the issue being, I can definitely take away more than 1. So I'll just take away 1 again. And we're still, so it looks like we're going to be able to take away 1 more time. So I took away 1, I took away another 1, and now I'm taking away another 1. And then I'm going to talk about another way we could do this. It's a little easier. So that is, I'm going to do 34 over 25 minus 25 over 25. Under 25. So the 34 minus 25, and that should leave me with 9. All right. So I ultimately took away 3 from this. And so I take that 3 over here, add it to my whole part, which would give me 47, and I'm left with 9 over 25. Now, another way you could have went about this is just simply divide 25 into 84 and see how many times it goes. It goes 3 times. 3 times 25 is 75. And so to get this part is the remainder of that division. So, which is a little quicker than breaking it down this way, but I wanted to show you how it was breaking down when you're going to take away more than 1 from that fractional part. Okay, so make sure I didn't make any more silly mistakes. And hooray, it's right. So I do apologize for this one. As I said, I actually made 2 mistakes on it. I'm going to turn back the page real quick to my original, which was to add all these up. And the best way to do it, again, was times 2. And again, I inadvertently forgot to multiply the fractional part that I should have. And then I also had the 18 plus 26, which I called 34 when it was 44. So those are my 2 mistakes. Oops. There we go. So here was the redo of number 10. And this is now correct. All right, so recapping again, to do this operation, when multiplying a number, counting number times a mixed fraction, multiply both parts, the whole part and the fractional part. That got me to my 18 over 8/5. And then this one was 26. 2 times 13 is 26. And then the 2 times the 22 25ths. Again, you would multiply just by the numerator. So this is like 2 over 1. Then I rewrote my denominators to both be 25 by multiplying top and bottom to be 5, or by 5. So I got my denominator 25 here. And this one already had the denominator 25. Then I added the whole parts, which gave me 44. And add the numerators over the common denominator of the fractional part. Then, because this is improper, I wanted to take away whatever I needed to, which in this turned out to be 3. And again, the quickest way to do it is just take the denominator, divide in the top. It went 3 times with a remainder of 9. And then that is my final answer. And this was just to show you if I took away 1, I kept taking away 1 until I made it proper. All right, again, I apologize for the mistakes, but we're good there. Are there any questions on this one?
No, but I do have a question of, like, if you were to take the 84, the 84 and divide 25 into it, and you get 3.36.
Okay, so yeah, when on your calculator, when you make the division, it's going to, if it gives you a decimal, that says it didn't go evenly. The number to the left of the decimals is the quotient. That's how many times it goes.
Right.
Now, what did you say when you divided it? Or I can divide it.
3.36.
36. The decimal part right here is not the remainder. It's the decimal form of a fraction. And that fraction is the remainder over what you divided by. That is 9/25.
Right.
This part. So what you can always do is you divide on your calculator, 25 into 84, got this. So you know it goes 3 times. So you know you're going to take 3/44 plus 3 is 47. To find your remainder, take what it divided, how many times it divided by, the quotient, times what you divided by. That is 3, in this case, you divided by 25. So take this times 25, which gives you 75, and take that away from what you were dividing into. And that will work every time to get you the remainder. So as another example, if I had, just making up something here, 72, and say I was dividing that by 13. Now, on my calculator, I'm going to go 72 divided by 13. And I'm going to put squigglies here. 5 point, and I picked one that I knew was going to give me a lot of decimal values. 5, 3, 8, 4, 6, 1, 5, 3, 8. Now, so this decimal part, again, is a fraction, and it's the remainder of the divisor. So if I were to write this as a mixed fraction, I would know the whole part's 5. I also know the denominator of the fractional part's 13. Now I just need the remainder. And what I would do simply is go 13 times 5, which is 65. And then the 72 minus 65 gives me a remainder of 7. And if you were to punch on your calculator 7 divided by 13, you would just get that 0.538446, etc. So I'm not sure that was exactly what your question was, but I thought that's where you were headed with it, how to find the
Yeah,
remainder.
it is.
Okay.
Like, I didn't know if we were supposed to just memorize the fact that these decimals equal a certain fraction, or
No. Sometimes you'll know them. Like if you get 0.5 and you divide it by 2,
Mhm.
you know the remainder is 1. I mean, that one, will stick. But no, you don't have to memorize them. I don't. I just, once I, get that decimal form, I said, I know how many times it went, and then I'll just take my divisor times how many times it went and take it away from what I was dividing into to get the remainder. So no, you don't have to have those memorized. Absolutely.
okay, that's good.
Yeah, that would be a lot. So needless memorization there for sure.
Okay,
And that honestly is about as hard of arithmetic as you're going to see in terms
well, that's good
of,
to know.
yeah, in terms of working with mixed fractions. I mean, those numbers, this problem we did right here. It's
3.36. The 9/25ths, we would multiply the 9 by the 3.
okay. So to get from here to here,
Mhm.
so what I did was first figure out how many whole parts I can get out of the 84/25. And so I
Right.
would just take my 25 divided into 84, and that's where we got this.
Right.
So I know that I can get 3 of them out because that's to the left of the decimal point. And so you can see where I went from 44 to 47.
Okay, my
Then-
question is exactly, I know if you take 9/25ths, if you know what that is, I know if you take 25 into 9, that's what you get, is that. But how do you get from the 0.36 back to the 9/25ths?
Okay, so all right,
That makes sense?
I think
Without guessing, it's 9/25ths,
okay,
or
so
looking it up somewhere.
I'm going to erase this 9 for a second. Like we haven't found it yet.
Mhm.
All right, so I took my 25, I divided it into 84, went 3 times, 3.36, but I know it went the whole part went 3 times.
Right,
And I went 44 plus 3 is 47.
right.
Now, the fractional part, the denominator won't change. So you can
Right.
see where I got my 25. So to figure out what number goes here,
Hmm.
that's where I go 3 times what I divided by. That is, I'm going 25 times 3. I get 75, and I then take that number away from 84. 84 minus 75 is 9. That's how I know what.
That makes sense.
Is that better?
Yeah.
All right. So what I was doing right here was the same thing without using my cal. I was just taking away 25 over 25 and did that, kept doing that how many times I needed to until I got a proper fraction.
Right.
Which if it divided into it 10 times, that's not a very efficient way to go. That was just kind of showing why it's working. And we use the division to be quicker about it.
Yeah.
All right.
Thank you.
Yep. Now, you've got another problem. The next problem where it actually asks you to plot on a number line. It's just giving you a mixed fraction. And then you're given 4 choices on a number line of where this number should be. So what you really want to do is write this as a mixed fraction to get a sense of where it would fit on the number line. So in this case, this is one we should be able to do in our head. That is, we say 3 divides into 4 one time. Denominator will still say 3. Notice that the process is still the same. I would say, well, 3 times 1 is 3, and 4 minus 3 is what? 1. And so 4/3 as a mixed fraction is 1 1/3. And then in looking at all your choices, there's only one that's clearly would be setting at 1 1/3. One of your answers is at, looks like 1/4. One of your answers is at 3/4. One of your answers is bigger than 2. And there's one that is setting between 1 and 2 at 1/3. 1/3 beyond 1. So, but when you get to this problem where it says, plot the point on the number line, convert it to a mixed fraction. And then there's just a few more like that. There's a few where you're comparing fractions. So we'll look at number 14. It gives you 1/2 and 1/25. Now, there's a couple ways you need to decide, is 1/2 greater than or less than 1/25. If you use your calculator, you can just put them in as decimal forms. That is, go on your calculator and go 1 divided by 2. So this is one way to it, is 0.5. And 1 divided by 25 on your calculator. In decimal form is 0.04. So fairly clearly, that's got to be bigger. 0.5 is bigger than 0.04. If you don't put them as in decimal form, you want to leave them in fractional form, rewrite each so they have the same denominator. And if you have the same denominator, then you can just compare numerators. So if I were to rewrite each of these with the same denominator, the LCD would be 50. That is, I would multiply top and bottom here by 25. And sorry, put the answer in there. We'll drop right here. We're comparing these two. So doing this by, again, rewriting each with the same denominator, multiply top and bottom by 25. That would give me 25 over 50. And here, multiply top and bottom by 2. So now you're comparing 25 over 50 or 2 over 50. And then, so if the denominators are the same, they have the same, then it's just compare the numerators, and certainly 25 is greater than 2. So I still get to the same answer. So I could either get your calculator, get the decimal form of each and compare them that way. Or if you're going to leave them as fractions, rewrite each with the same denominator to do the comparison.
And Chris, can you do the equation again where you made the 1/2 0.5, the 1/25?
Well, all you do on your calculator is go 1 divided by 2. And now, if you're using that TI-30XS and it's got its setting to write all answers as fractions, it's just going to spit 1/2 back at you again. Is that what's happening?
Yes.
Okay. So if you got your phone and went 1 divided by 2, you would get 0.5 as the answer.
Okay, I get that.
So there is a setting, and I'm going to have to figure it out because I'm able to go 1 divided by 2 on my calculator. I just have to figure out. Well, that ain't it. Okay, do this, David. So on your TI-30, go 1 divided by 2 and tell me if you got 1/2 as your answer.
Yes, that's what I got.
Okay. Now this is where I wish I had my emulator that I could put the calculator up to the screen. I'm going to have you find a second function. So the way I'm going to do it is look at, so you see where your oval directional arrow button is, right? Over on the right side, top.
Yes.
All right. Directly below it, you'll see a key that says table.
Yes.
Second function, you see where it says F, arrow D.
Yes.
That's a toggle between fraction and decimal. So right now, I want you to hit second and that button, and then hit enter. And it should have converted it to 0.5.
It certainly did.
Okay.
All right. So if I remember that, yes.
So
Okay.
just remember, if you have a fractional answer, go to that button to change it to decimal form.
Right.
No.
Okay. Now that's good. Yeah,
Yeah.
because my question was, it kept me just at 1/2 when I did
Yeah.
it.
And so it's that one, see, like on a TI-80, you don't get that fraction. It just gives you the decimal form, and then you can convert it to fraction. This will go both ways
Okay.
with the TI-30 XS.
$20 well invested.
Yep.
Yeah, that's why we like to use that for this class, because of its affordability. And as I said, it just in the ability to work the fractions on the calculator alone pretty much sells it. If I were, for most math students will say, what's the one thing you hate to work with the most? It's fractions. So, of course, I guess all depends on what you do in life. Like if you do construction or any kind of building, your world is fractions. So,
Yeah.
So there's only a couple other problems in this section. If you have fractions that you are raising powers, so such as 4/3 to the 4th. So again, what does an exponent mean? Multiply the base with itself that many times. And so what this becomes is raise top and bottom to that power. And so this would be 4 times 4 times 4 times 4, which is 256. And then the bottom is 3 times 3 times 3 times 3. I think I said that 4 times, which would be 81, and done. Now, on your calculator, you're able to actually do this too. You can punch in parenthesis and then hit one of two ways. You can do the fractional button, n over d, or you can just go 4 divided by 3. So I'm going to test it out to make sure I can do it that way. Parenthesis 4 divided by 3, close parenthesis. Caret key over on the left, that is the upside down. When I say caret key, it's the one that looks like that. That raises powers. 2, 4. Now it gave it to me as a decimal. I'm going to do the second table. And it gave me 256 over 81. So again, the buttons, if I would push on the calculator, I would go 4 divided by the quickest way, 4 divided by 3. You hit the caret key. And so the key actually, it'll look like that. That says raise it to the power of 4. Now, when I hit enter, I got a decimal, 3.16049, blah, blah, blah. Then I did the second table and enter, and that converted it, and I got my 256 over 81. All right. And so in this one, this finishes out the kind of chapter 2 fractional stuff. So there's a section 2 quiz. I've got the 30th, which is Wednesday, is the due date on each. And I'm assigning both of these right now. All right, so they are assigned. So I think there's 17 problems total dealing with the fractions of 2, 3, and then there's the section 2 quiz. It's got 10 questions total on the quiz, and that would cover 2, 1, 2, 2, 2, 3. All right. Any other questions from you guys?
No, today was very helpful.
Good deal. Good deal. All right, gang. So I will see you guys on Wednesday. Yep, Wednesday at 11. So be safe and stay cool. It's a little warm out there right now.
I wonder why you had long sleeves on.
Well, I'm in my basement with the air conditioning right this second, but I'm getting ready to go out and work in the yard. So
yeah, make sure you use sunscreen.
Oh yeah, definitely. Yep. Thank you, and I'll see you guys on Wednesday.
All right. Thank you. Bye, Chris.
See ya.